Hello students, welcome back. So in this lecture we are going to continue our second chapter of physics, that is units and measurement, and we were left with one topic in the previous class. So let's continue with this topic. We were left with types of error in measurement. Therefore first one is systematic error, second one is random error, and third one is gross errors. So first of all, let's discuss about the systematic error. So as you are getting from the name, that is systematic. That means the error which is due to the system is called the systematic error. The cause of systematic error are known to us and it can be minimized. As I told you, it is because the system, so the cause of this error are known to us and it can be minimized with the help of some basic knowledge. Therefore, the systematic errors are: first is instrumental errors. In instrument, the error arises due to the imperfect design. Suppose you are buying a scale from a market and the scale is defected, is having something this kind of shape. So this is comes under the instrumental errors. That means the equipment or the instrument you are buying from the market are having some defects, are called instrumental errors. So it can be minimized easily. Second one in this category is imperfection in experimental technique. So let's understand with the help of an example. Suppose if you are having the fever and you go to the doctor, so it will put a thermometer under your armpit. So it will give you a different body temperature lower than the actual value of the body temperature. So that means there is some problem in the technique. So this is the imperfection in experimental technique. Next one is personal error. Therefore, the personal error is arise due to the inexperience of the observer or defect in the eyes. Suppose you are taking a child with you to measure the reading with the help of a scale, but that child doesn't know how to take the reading from the scale. So this is because of lack of knowledge of the child. You will get a error in your reading, so that is come under the personal error. In this category, next one is error due to external cause. Therefore, the external conditions such as changes in temperature, pressure, humidity, wind velocity, etc. during the experiment may affect the measurement. Suppose you are playing in the ground and you want to take the reading that how fast you are throwing a ball on the wall. So suppose there is wind blowing at very high intensity, so it will definitely affect in your experiment. So this is the error due to external cause. Next one is least count error. So first of all, let us know what is least count. The smallest value that can be measured by a measuring instrument is called least count of the instrument. So this is the definition of least count. So least count is the smallest value that can be measured by a measuring instrument is known as the least count. For an example, in our meter scale, we are having 0.1 centimeter least count. As you see in your meter scale, uh, suppose this is your meter scale and here it is 1 centimeter, here it is 2 centimeter. So if you notice, there have 10 lines in between. So these lines is basically 0.1 centimeter, that is 1 mm. You can even call this 1 mm, that is 1 millimeter. So the least count of your meter scale is 0.1 centimeter, that is your meter scale. If we talk about the vernier caliper, it is having least count carelessness of the observer. So this error is all depend on the observer, how he is taking reading and on what condition he is taking reading. So it's all depend on the observer. For an example, first is reading an instrument without setting it properly. Second is taking the observations wrongly without caring for the source of errors. And third one is recording the observation wrongly. And fourth one is using wrong values of the observations in calculation. So gross error are having some example. As I told you, first one is reading an instrument without setting it properly. Second is taking the observation wrongly without caring for the source of errors and precaution. Third one is recording the observation wrongly. Fourth one is using wrong values of the observation in calculation. Now we have some other errors, in which first is absolute error. So in absolute error, in the measurement of a physical quantity, in the measurement of a physical quantity is the magnitude of the difference between the true value and the individual measured value of the quantity. So absolute error in the measurement of a physical quantity is the magnitude of the difference between the true value and the individual measured value of the quantity. So let's understand with the help of an example. Let a physical quantity be measured n times. Suppose I am performing an experiment and I measured a physical quantity n times and I got the readings, that is A1, A2, A3 up to AN. So I got this reading that is up to the n times, that is a1, I got the readings up to the n times, that are a1, a2, a3 and so on. Now I am finding the mean, arithmetic mean of these experimental value. So the arithmetical mean of these values are a1 plus a2 plus a3 up to an and divided by n, because we know the arithmetic mean is sum of all the observations upon the number of observation. So we observed the get the experimental value up to the n terms, that's why we observed the n experimental values and we put the n because we performed it n times. So we get the mean value, that is am. Now the arithmetic mean am is taken as the best possible or true value of the quantity if the same is not known. Otherwise, delta a1 is equal to am minus a1, delta a2 is equal to am minus a2. So this is basically the absolute error that we got in the definition. In the measurement of a physical quantity is the magnitude, that is the magnitude of the difference between the true value, that means this, and the individual measured value. In the measurement of a physical quantity is the magnitude of the difference between the true value and the individual measured value of the quantity. So delta A1 is basically the difference between the arithmetic value and the value that we observed, that is individual value. So it is up to the n times. So this is the absolute error. So in some cases the absolute error may be positive and in certain cases it can be negative. This is because the individual measurement are as likely to overestimate as to underestimate the true value of the quantity. So it is all about the today's video, and we will continue the error topic in our next video. Thank you.